Heat of displacement. The heat of displacement is the heat change when 1 mole of a metal is displaced from its solution by a more electropositive metal. When a more electropositive metal displaces a less electropositive metal from a solution of its source, heat change occurs. The heat of displacement of a metal can be determined by measuring the heat change occurred when a more electropositive metal in excess is added to a known quantity of a salt solution of a less electropositive metal. The heat of displacement of a metal is different when it is displaced by different metals in the electrochemical series. Based on the displacement reaction between zinc metal and copper to sulfate solution, the question is calculate heat of displacement. First step, write balanced chemical equation for the displacement reaction, and then calculate heat change by using the formula mc theta. The displacement reaction is exothermic reaction because the temperature of the solution increases. And next, calculate the number of mole of copper to sulfate solution given in this situation. We cannot calculate the number of mole of zinc because the zinc powder used in this reaction are in excess. Number of mole of copper to sulfate will be used in the proportion to get the number of mole of copper displaced from its solution. So we know here 1.176 kilojoule of heat released when 0.0105 mole of copper metal displaced from its salt solution or from copper to sulfate solution. And then to get the heat of displacement, we need to make proportion between number of mole of copper displaced with the quantity of heat released to get the quantity of heat released when 1 mole of copper metal displaced from copper to sulfate solution. This is because the definition of heat of displacement is the heat change when 1 mole of a metal is displaced from its salt solution by a more electropositive metal. Heat of displacement between zinc metal with copper to sulfate is negative 112 kilojoule per mole. 112 kilojoule of heat released when 1 mole of copper metal is displaced from copper to sulfate solution by zinc metal. Heat of neutralization. Neutralization is the reaction between an acid and a base to form a salt and water. During neutralization reaction, hydrogen ions from acid react with hydroxide ions from alkali to form water. Since water is formed during neutralization, heat of neutralization is defined based on the formation of water. The heat of neutralization is the heat produced when 1 mole of water is formed from the reaction between an acid and an alkali. Neutralization is an exothermic reaction. Neutralization always produces heat. Therefore, heat of neutralization is always negative. The heat of neutralization between strong acids and strong alkalis are always the same. But heat of neutralization between a weak acid and a weak alkali is the least than heat of neutralization between a strong acid with a strong alkali. This is because more energy is needed to dissociate both the weak acid and the weak alkali completely to produce hydrogen ion and hydroxide ions, which then react together to form 1 mole of water. So the value of the heat of neutralization depends on the basicity of the acid, the strength of the acid and the strength of the alkali. Refer to the example of the neutralization reaction between hydrochloric acid and sodium hydroxide. To calculate heat of neutralization, the first step, write down balanced chemical equation for the reaction between hydrochloric acid solution with sodium hydroxide solution to form water and sodium chloride. And next, calculate the heat change or heat release from the reaction. Here, 5.168 kilojoule of heat release, and we can know that this reaction is exothermic reaction because the temperature of the solution rises from 30 degrees Celsius to 41.5 degrees Celsius. And then calculate the number of mole of hydrochloric acid solution and number of mole of sodium hydroxide solution by using the information given in the situation. From the calculation, number of mole of hydrochloric acid and number of mole of sodium hydroxide, the smallest number of mole is the number of mole of sodium hydroxide, 0.0855 mole. So we use the number of mole of sodium hydroxide solution in the proportion to get the number of mole of water produced. To get heat of neutralization, we need to make proportion between number of mole of water produced with the quantity of heat released to get the quantity of heat released when 1 mole of water produced. This is because the heat of neutralization is the heat produced when 1 mole of water is formed from the reaction between an acid and an alkali. So here we can say that the heat of neutralization between hydrochloric acid and sodium hydroxide solution is negative 60.4 kilojoule per mole. Negative means the reaction is exothermic reaction, and the unit kilojoule per mole means 60.4 kilojoule of heat released when 1 mole of water produced. Heat of combustion. A fuel is a chemical substance that burns in oxygen to produce heat energy. Combustion is a chemical reaction between a fuel and oxygen to release heat, so that combustion is always an exothermic reaction. The heat of combustion is the heat produced when 1 mole of a substance is completely burned in oxygen under standard condition. Different fuels have different values of heat of combustion. The value of heat of combustion is an important factor for us to decide what fuel to use for a certain purpose. The heat of combustion of a fuel can be determined accurately by using a bomb calorimeter, because a bomb calorimeter is specifically designed to minimize heat loss to the surroundings. In the laboratory, the heat of combustion of a fuel can be determined by calculate heat absorbed by the water. The heat given out by the fuel is calculated. We assume that all the heat given out during the combustion of the fuel is absorbed by the water. This is the example of combustion reaction between ethanol with oxygen to produce carbon dioxide and water. This is the complete combustion reaction. First step, write down balanced chemical equation for the reaction between ethanol with oxygen to produce carbon dioxide and water. And next, calculate heat change using the formula heat change equal to mc theta, where m is the mass of water used. This is because we assume that all the heat given out during the combustion of the fuel is absorbed by the water. Heat given out during combustion of the fuel equal to the heat absorbed by the water. So the heat of combustion is the heat given out by 1 mole of the fuel will be calculated. Then calculate number of mole of the fuel. In this case, the fuel is ethanol. Based on the value of the heat change and number of mole of fuel, we know that combustion of 0.0065 mole of ethanol produce 8.4 kilojoule of heat or 8.4 kilojoule of heat release. To calculate heat of combustion, we need to know the value of heat release when 1 mole of fuel used. Heat of combustion of ethanol is negative 1292 kilojoule per mole. The combustion reaction is exothermic reaction and 1292 kilojoule heat release when 1 mole of ethanol react completely with oxygen.